Imagine you are the only chef in the kitchen. You are chopping vegetables and then you heard a ding sound. Your microwave is indicating that the pasta you are boiling inside it is done. What would you do in this case? You probably won't stop chopping the vegetable immediately. You will finish your work, then you'll go towards your microwave, take out the pasta, and you'll start working with it. That's exactly how JavaScript also works. JavaScript is synchronous and single threaded. It handles one task at a time. So what happens when you ask to fetch some data by calling some API, or you wait for some time for a function to execute, for example using setTimeout? If JavaScript has to wait for these things to happen, could you imagine what will be the situation of your application? Your application will be frozen because until unless the fetch API call for getting the data by calling an API or the set timeout execution finishes, nothing will move forward. That will be really a bad thing to happen, right? This is exactly where event loop comes. Now imagine event loop as your kitchen assistant. You are chopping the vegetable, and at that time your microwave ring. Okay, the boiling of pasta is over. Now you really don't have to go over to fetch the boiled pasta. Your assistant can very well do that. While you are finishing chopping the vegetable, the assistant can take out the pasta from microwave, can do all required dressing, can perform all other things on it while you finish chopping the vegetable and join your assistant to do further job. As a chef, as it helps you to work efficiently, event loop makes sure that your code works efficiently in the asynchronous situation. Hey, this is Tapas. Welcome back to 40 Days of JavaScript. It is day 27, and today we are going to talk about a very important topic from JavaScript, especially from asynchronous programming, is called event loop. There are many ways event loop is going to impact you in your development journey. One, if you want to understand what's going on with your asynchronous code, if you have to debug it, if you have to debug somebody else's code or you have to debug your code, if you have to do really well with JavaScript based interview, with web development interviews, you have to have some knowledge of event loop, how things works, so that you can easily tackle all those situations. Event loop is just like mathematics. There are few formulas, there are few logic, and if you just by heart them and practice a few examples, boom, you're done with it. So without any further delay, let us get started understanding event loop. One prerequisite to understand event loop, you should have knowledge of how JavaScript function works, what is callback, how set timeout, set interval, all these things work, how promises work. Everything we have covered so far in our 40 days of JavaScript. So if you're a beginner to JavaScript, just landing into this video to learn event loop, I would suggest first you cover the video for function, then look into the promise video, and then come to this one. It will make a lot of sense to you. Let's get started. As I told that to understand event loop well, you need some preliminary concepts like functions. While explaining functions, we discussed about function execution stack or call stack. Let's do a quick recap of it because we'll be requiring to understand and work with call stack a lot when we are talking about event loop. What is a call stack? When JavaScript execute a function, it creates a function execution context. We know about global execution context, function execution context in depth from our previous sessions. What is function execution context? In function execution context, there will be two phases we know. One is the creation phase, another is the execution phase. Now, when JavaScript has to execute the function, it means anything written inside the function, line by line, JavaScript has to execute. It will place the function in a data structure called stack. What is stack? By data structure, it is first in and last out. What gets in first, that comes out last. So one by one, as JavaScript encounter functions, is going to put those functions inside the stack. Think in this way at a high level. And once the execution of the function is over, it will take out the function from the stack. What is the advantage of doing it? JavaScript can track how it is executing the function, what is the order of it, and to maintain a reference of what function has been executed and what is being executed and what is going to get executed. That is where the call stack come into picture. Everything in the call stack is very much synchronous. As JavaScript sees the functions line by line to execute, it puts into the stack. Once execution is done, it takes out of the stack. Very, very simple. Now let's take a quick overview of how call stack and the function execution works together with a couple of examples. You must have seen some of these examples in the earlier session, but it's good to recap again because you're talking about event loop and this is important. So here on the screen, we are able to see three functions. In the left side on the yellow background area. We have first F1 at the top over here with bunch of code, then F2 again with bunch of code, then F3 again with bunch of code. And then we execute F1. Execute means we call F1, then we call F2, then we call F3. So how our function execution stack or the call stack will be impacted if I execute this code this fashion. So let's take a look. First and foremost thing, F1 will be executed, right? So you have highlighted F1. The moment F1 wants to get executed, F1 gets inside the call stack we see over here. Now inside F1, we are not making any other function call. So all this instruction will be executed one by one. And once the execution of F1 is over, then F1 will be coming out of the stack. F1's execution is done. Then F2 will be executed. Again, F2 got highlighted over here, we are seeing. And then F2 gets inside the stack. Again, F2 doesn't have any function inside it as such, which is getting called. So it will be executed and coming out. Then similarly, the thing will happen for F3 as well. So this is pretty simple example of sequential execution of functions and how call stack getting impacted with it. Now let's take one more example. This example is little more complex than the previous one. What is happening here? We have again a function F1, the standard set of instructions inside F1. Then there is a function called F2. There are few lines of code, and then we are invoking or executing the function F1 from F2. Then I have another function called F3. Inside that I am invoking F2. And finally, I'm calling or executing F3. So how the chain happen? F3 gets executed, called or invoked, whatever you say. This invokes F2. F2 invokes F1. This is the chain. So how now things will happen inside the call stack? Let's see. So first thing, F3 will be executed, right? In the execution context. As F3 gets executed, F3 gets inside the stack. Excellent. Now we'll go inside F3. Inside F3, we see one more function called F2. Now look at this. At this stage, F3 will not come out because the execution of F3 is not over. We are still inside F3. But we encountered another function call, another function execution. The moment we encounter that, F2 gets inside that. Great. So let's execute F2. Once we get inside F2, we execute this line of code. Maybe there are certain variable initialized, all these things. Oh, then we see something called F1. But till this time, F2's execution is not over, so I cannot take out F2. As F2 is called inside F3, so it means that F3's execution is also not over till now, so we cannot take out F3, but I have to put F1 inside it. I put F1. Now I go inside F1. I execute all this code one by one. There is no more function call. F1 gets executed completely, so F1 come out of the stack. So F2's everything is done, so F2 will come out of the stack. Then finally F3 will be coming out of the stack. So this is how the execution happens pretty sequential manner, right? Now the question is, when something asynchronous happen, what will happen then? So let's take some example of asynchronousness first. We learned JavaScript is synchronous. There can be async behaviors. For example, with browser APIs, or we also call it as web APIs, like set timeout, set interval, we can achieve some async operation. For example, set timeout, you give a function and tell that function to execute after a certain time lapse. But in that time lapse, in that moment, you really don't want to wait, right? Otherwise, your UI might get frozen. Then other things could be with promises. Then another example could be with event handlers. Imagine you have a button and you have a handler function written such that when someone click on the button, that particular function gets executed. The function never gets executed sequentially. It happens only when someone click on it. So that's another asynchronous operation. So there are a bunch of asynchronous operation based on which, again, the function can be invoked. If you click on a button, based on a click, you can invoke a function. Based on set timeout, after a time lapse, you can invoke a function. Now imagine what happened to those function. Does those function also goes to call stack? If those function goes to call stack, does it block the behavior we have just now seen in the call stack? Call stack is very sequential, right? If all these functions that are part of asynchronous behavior, if they also go to the call stack and execute sequentially, we have a high chance that our JavaScript code become completely synchronous. It will probably freeze our UI, isn't it? but that's not the case. This is where the event loop come into picture. So let's get into the details of what is event loop and what are the things are part of it. The things we will discuss today as part of event loop are: one is called call stack. We have discussed this already. Second is web APIs like set timeout, set interval, fetch, DOM events, click events, all these things. Then we'll talk about something called a callback queue. Okay, very important concept, and we'll see it visually. What is callback queue at a high level? You can think about it as a storage where JavaScript will store your callbacks momentarily before it get put into the call stack. Then we will talk about something called a Microtask queue. It is also known as a job queue. What it is, this gets used for the promises. This is again, think about a storage where the handler function, we know about handler function on the promises, right? That gets placed and eventually it goes to call stack, like how these things gets managed. And then the final thing is the event loop itself, which manages what to run next on the call stack. Okay, so call stack, which manages the execution of the functions, web APIs, set timeout, fetch, DOM events, click events. Callback queue, a temporary storage of the callback functions. Microtask queue, a temporary storage of the promise handler function. Event loop is a manager orchestrator that manages what to run next in the call stack. Okay, so this is the definition. But this definition, I'm sure, is not enough. We have to do something visually to understand it better. So here is a diagram. I want you to remember, recollect, by heart, and keep with you forever. Okay, let's understand what it is. This is an imaginary depiction of how JavaScript engine manages different places, sections, data structure to manage its function execution, to manage the promise execution, to manage the browser API execution. Thus, the sequential code execution versus asynchronous code execution. Okay. So what are the things available? Call stack. We have already seen it, not to talk about it. Just now I spoke about something called callback queue, which is also called a task queue. It's a temporary storage for keeping the callback. And there is a storage where JavaScript engine keeps its browser APIs. Whenever in the code it sees a set timeout or a fetch API call or an event callback, it can store that particular function momentarily in a place that you can imagine is something like this, where it will store the browser APIs. And in between, there is somebody called event loop. This is called loop because it iterates. What exactly it does in the iteration? In every iteration of event loop, its only job is to look into whether my call stack is empty or not. If my call stack is empty, let me see if I have anything in my callback queue or not. If I have anything in my callback queue, I will pull the things from the callback queue to the call stack. This is his job. Okay, please note it down. The job of event loop is to iterate and look into whether the call stack is empty. If the call stack is empty, look into the callback queue and see if there is something in the callback queue, then pull that from the callback queue to the call stack so that that particular item, that particular function gets executed. What goes inside callback queue? A callback. What is a callback? Is a function. And what goes inside the call stack? A function, right? So everything is kind of matching. That's why I was telling that understanding event loop is just like math. Now, what if there are multiple callbacks got accumulated inside this callback queue? What is a queue? It's another data structure just like stack. In case of stack, it is last in, first out, or first in, last out, whatever. So the elements that gets in last comes out first. That's we know about the stack. But in case of queue, it is first in, first out, FIFO. The item that gets in first comes out first. So if there are multiple functions in this area, an event loop has to pull out the function one by one to call stack, it will follow the philosophy of queue itself, which is FIFO. So the function that got inside the queue first will go to the call stack first, then the next one, then the next one, in that particular manner. I hope this diagram is clear to you. Now what we're going to do, we are going to take one code example and then try to understand how that code example will execute in terms of all this structure that we are showing here, like stack, queue, and this overall diagram along with event loop. Take a look into this code. I have a function f1 which logs the string f1 on the console. Then I have a function called main. Inside that I have a set timeout which executes this particular function. Okay, this anonymous function which I have written using arrow function. And once this function gets executed, it logs another console.log on the console, but this function gets executed only after 5 seconds because I have given a time duration over here, and that's how setTimeout works. After this, what I do, I call f1, the function f1, which will log the string f1. Then finally, I call main over here. So what will be the output of this code execution? So I see f1, and I believe after a few seconds, the next log will come with inside setTimeout. Yes, I see that. Now what happened over here? If I look into the code, the inside setTimeout is actually there before f1. So expectation wise, this guy should have come, this log should have come before f1's log, isn't it? If that was happening, then this code will be halted here for 5 seconds before f1 gets executed. Maybe inside f1, you have just printed something on the console, and here you wanted to get some data from your API. Now this may take a while, and if you are blocking the execution of f1, you will make a disaster, right? Your application is literally frozen for 5 seconds, nothing is happening, and then the rest of the execution will start. You don't want that to happen. Even JavaScript doesn't want that to happen. That's the reason f1 gets executed, but the execution output of the set timeout comes back only after this 5 seconds is elapsed, and this all managed using event loop. Okay, with this we probably can make our mind in a way, oh fine, after 5 seconds it has to come back, so this is good. Now, can I just remove this 5 second and make it as a 0 second? What will be the output in this case? Now it doesn't have any delay, right? So it means that this should execute it immediately. So I should get inside set timeout first, then f1 should get executed immediately, then I should get the f1 log in the console.log. So the order, it should happen inside set timeout and then f1. But let's see in the output. Oh no, output I see f1 first and inside set timeout after that. Even though inside set timeout happen instantly, if I refresh the browser, I'll see instantly it is happening. But still, f1 is getting printed before inside set timeout. Why? Why exactly it's happening this way? So all this answer is what we're going to get using the visualization. But before that, let me make this code little bit more complex for you. So the only complexity I got over here, I have introduced one more function called f2. Like previously, we have the function f1, which logs a string called f1 in the console. Then there is another function called f2, which again log a string called f2 in the console. Then like before, we also have a main function. Inside that, now we do a console.log of main. And then we have a set timeout of f1 with 0 milliseconds. That means immediately you execute the function f1 without any delay. That's why it's 0 millisecond. And then we are calling this f2. So this f2 and calling this f2 after this is the only difference other than the console.log of main over here. And then the main gets executed. Now what will be the output of this particular code? That's the first question. Second question is, explain this in terms of event loop. How the code execution will happen, how as a JavaScript engine you think this code will be executed. This is how interviewers ask question in interview, and you need to be very smart to answer that. Will the output be main f1 f2, or it will be like main f2 f1, or it will be like f1 f2 main? What it will be? Now this is where I want to explain this pictorially, visually, with the diagram that we have seen, where we had call stack, the place for the browser APIs or the web APIs, and below the callback queue. What is a callback here, guys? Let's recollect. A callback is a function that you pass as an argument or the parameter to another function. Correct, na? That's a callback function. Which one is a callback function here? Is console.log, this is a callback function? No, this is not a function. Is main having a callback function? No, main is not taking any other function as an argument. But do you see set timeout is a function? It has a name and the parenthesis, and it takes another function f1 as an argument, right? F1 is another function. So it means that f1 is that callback function. Okay, f1 is the callback function because it get passed as an argument to another function. So in this code example, we have one callback function to handle, that is f1. Please keep in mind. Okay, because we have something called callback queue and we have one callback function to handle. Now let's go to that diagram. The same code with the diagram. Now how the execution will happen, let's see. JavaScript engine will first see, okay, there is a function. So it's in global execution context. It will put and create the function in the memory. We learned that. Then same for f2, same for main. Now in the global execution context, execution phase, it will find the function main. This is where learning from the basics and the fundamental is so important. If you are coming from the execution context video, you know this is a cakewalk. You must be actually getting excited that you have learned the execution context, and so why you are understanding it so beautifully. So the first thing that will be executed in the global execution context execution phase is the main function. So main will go inside the call stack. Okay, so far so good. The moment main goes inside the call stack, it will start executing whatever is there inside the main. What is there inside the main? The first line is the console.log. So the first line console.log main will be executed. Now the twist. Now in the second line, it sees set timeout. Will the set timeout go inside the call stack? This is where another rule comes. Please note down. The web APIs or the browser APIs like set timeout, set interval, your event handler methods, JavaScript is going to park them somewhere here. Okay, JavaScript is going to park them somewhere here. But the moment it says set timeout, it is going to park them somewhere here. And after parking, what will happen? There is a callback function called F1, isn't it? This F1 callback. The F1 goes inside this callback queue. Understand it well. The callback function that we pass to the set timeout goes and gets stored temporarily inside a callback queue. It doesn't go inside the call stack at all. Okay. Set timeout with this timer, like after which interval this particular callback has to be executed. That information is there somewhere over here, and that particular callback goes inside the callback queue. The execution of the main never gets halted because there is nothing which is related to set timeout or this callback in the call stack right now. So the execution will proceed. It means that what is the next line in the main after this set timeout line is the F2 will get inside the call stack because it's another function. Now F2 is having this console.log, so of course the console.log will get inside. After the console.log there is nothing else. Console.log comes out, F2 comes out. Okay, now execution of these things is over. It will go to the next line after F2. There is nothing to execute after this line of F2. That means the execution of the main is also over. Now the twist. Now event loop, as it was iterating and checking whether whether my call stack is empty or not, now it finds the call stack is empty. So that means now is the time that I can actually check into my callback queue and find out, do I have any function temporarily stored over there? If the function is temporarily stored over there, let's pull that function from callback queue to the call stack. So now F1 got inside the call stack. This is F1. So everything inside F1 will be executed. There is a console.log F1. That execution done. So F1 doesn't have anything else. F1's execution is done and F1 comes out. This is how the execution happens. Understood? Now what we are going to do, we are going to do a recap of it again and we'll print out like what will be printed in the console so that you clearly understand why the output is going to be main F2 F1, not main F1 F2. Looking into this, you might just guess that it will be console.log main. So main set timeout with immediate, without any time delay, F1 is getting executed. So F1 is the next one, and JavaScript is synchronous. It executes line by line, and then it will be F2. So main F1 F2, if it is your guess, is completely wrong because the way that event loop manages this execution, that will make sure that this set timeout is always treated as an asynchronous way, giving the way for every other synchronous operation to happen, and then only the asynchronous operation will be taken care. That's the reason the output will be main F2 F1. Let's do it again. All right, so we're starting. First main got inside. So what main is going to print is going to print this console.log main. So you get main. Now next line, this gone. Next comes set timeout. So to set timeout, is it going to get executed? No, it is going to be managed by JavaScript engine as an web API. And this F1, even though it is having a 0 milliseconds as a timeout, it is still going to go inside the callback queue. It is not going to go inside the call stack. That's how JavaScript engine manages, because it is an asynchronous operation. Even if the timeout is 0 milliseconds, still it has to be managed in this way. So as F1 didn't go inside the call stack, F1 is not going to get executed. JavaScript engine will proceed and it will bring the next thing what is there in the main function, that is F2. So it will execute F2. F2 is what? Console.log F2. It will execute. Now we will get after main F2 over here in the console. Excellent. Main and F2. So F2's execution is done. As F2's execution is done, there is nothing inside the main to execute, so main comes out. But now event loop looks into it like, hey, call stack is empty. I still have something into the callback queue. Let me pull this guy inside. Now F1 come inside. Inside F1, you have a console.log F1 that gets executed, and then you get in the console as F1. So first you get main, then you get F2, and then you get F1. This is the reason. So F1 gets out and your execution gets over. Did you understand how things works? Now anybody give you or try to trick you with programs like this, I think you have an answer, right? We are going to see one more example now, but with promises, right? And see how JavaScript engine and the event loop thinks through when there is a set timeout, there is a promise to deal with the asynchronous operation, and also there are sequential code like the functions, console.log, etc. Let's see that. All right, friends, time to look into this code now. And it's a little more complex because we have now got promises. So if you have understood how things happen with event loop by JavaScript engine so far, this will be pretty easy because just a very small addition. Like before, we have a function called F1. Like before, we have a function called F2. Like before, we have a function called main. Like before, we have a console.log main. But now in setTimeout, instead of writing an anonymous function over here, I am trying to execute this F1 itself. That's the first change. And again, just like before, there is no time lapse. Immediately, the function F1 should get executed using setTimeout. That's what we are doing. Now we have a promise, and the promise gets resolved immediately with a string saying I am a promise. And once the promise gets resolved, it gets logged inside the console. Okay, so this is the promise. And after promise, I am executing this F2, which logs F2 inside the console. After that, finally, I'm executing the main, this particular function itself. Now my question to you, what will be the output? Is the output going to be main F1, I am a promise F2? Or main F2, F1, I am a promise? Or main F2, I am a promise F1? There are a variety of combinations possible. Instead of guessing, if you think through event loop, if you think through all this logic that I have taught you, except this promise part, now you will be able to answer things pretty well. You will be able to answer this one, isn't it? First main gets logged. After main, it will see a set timeout. It won't execute it immediately. It will park it as a browser API, and the F1 will go to the callback queue. The main will move on its execution and it will put F2 into call stack. So F2 will get executed. So after main, it will print F2. Then nothing else to do in main. Call stack is empty. Now event loop will look into the callback queue. It will find F1. Then it will bring F1 to call stack. It will execute. F1 will be executed. So the output will be in this case main F2 F1. Now twist is I am bringing one promise. Now in this sequence, where exactly I am a promise will be logged. Okay, this is where debugging asynchronous code becomes very important, and if you know event loop, it is very, very easy for you. Let's see with the diagram again. The same diagram, but a bit of addition. We have the call stack like before, browser API section for before, callback queue like before, but we have now added something called a job queue or a microtask queue. Okay, why this job queue or the microtask queue exists? If it is an asynchronous operation using browser APIs like set timeout, set interval, then the event handlers, all the callback that gets inside that is going to get parked inside the callback queue. But if you remember, in promises also, we get a callback. How we create promise? We create promise using the promise constructor function that takes another function as a callback, as an argument, which we call as an executor function. From promise video, you are quite clear about this. So that handler function in promise is nothing but a callback. So whenever JavaScript encounters a promise, handler function of that particular promise will be parked inside the job queue. That is how, again, the execution inside the call stack, the synchronous execution inside the call stack will never be impacted or affected if we find a web API or find a promise on the way. For web API, the callback will come and temporarily be stored inside the callback queue. For promises, the handler function will be stored inside this job queue temporarily. And then the work of event loop remains same. It's going to check whether my call stack is empty or not. If my call stack is empty and I have something inside the callback, I will pick up the thing from callback and pull inside my call stack, just like before. If I don't have anything in the callback, I have something inside this job queue, Then I'll pull this thing from the job queue and put inside the call stack. Same thing. If my call stack is empty, I'll pull from callback. If something is there in callback, if something is there in job queue, I'll pull from there. What if there is a situation where you have both in callback and job queue? What will happen in that case? In that case, event loop always give the priority to the job queue. If there is a situation where you have function in both in the callback queue or the job queue, if and you have the call stack empty, event loop is going to pull the function from job queue first, execute it, and then it will pull the function from callback queue and execute it. Please remember, note down. Okay, I'm talking about formulas like how event loop works. Now there could be another situation and the last situation. What if there are multiple items in callback queue and there are multiple items in job queue? What will happen in this case? What is the formula? If there are multiple items in callback queue and there are multiple items in job queue, how event loop will treat it? In its iteration, if it finds the call stack is empty, it is going to take one function from the callback queue and execute it. But if there are multiple items in the job queue or the microtask queue, the event loop, if it finds the call stack empty, it will execute all the functions in the job queue before you start looking into the callback queue again. Okay, so these are the formula. Now let's recap the formula once more, all the formula. And I want you to take note so that next example that I'm going to show you visually, it makes a lot of sense to you. Okay, first formula. Everything and anything inside the call stack must be executed the way that we have seen in a last in, first out manner, the stack manner. Okay, there is no doubt in that. If there is a browser API or the web API that comes into the picture in the execution, that gets parked somewhere, and the callback function of that will be put inside in a callback queue or the task queue. If there is a promise encountered, the promise won't be executed immediately, of course. The executed function of that promise will be parked inside the job queue. Okay, you're writing, I hope. Now, event loop will keep checking whether my call stack is empty or not. The moment it finds call stack empty, it will see whether I have anything in the callback queue or the job queue or not. If I have something in the callback queue and my call stack is empty, I will pull this inside the call stack and execute as a normal function. If I find something inside the job queue, I'll pull that particular function from the job queue to call stack and I'll execute like a normal function. If I find I have function in both callback queue and job queue, I'll give the higher precedence to job queue. The functions inside the job queue, I'll give that as a higher precedence and I'll execute it before I come to callback queue. If I find there are multiple items in callback queue and the job queue, I would pick up in my one iteration one item from the callback queue, execute. But when I go to the job queue, in that iteration, I'll make sure that I clean this up completely before I look into the callback queue. Okay. So if there is one function over here and there is three functions over here, I'll first execute, I means as a JavaScript engine, will first execute all three, then to look into this one over here. That's the rule. These are the rules that you have to keep in mind, because now we are going to look into code first. The same code that I have showed to you over here, exactly the same code. I have the function f1, f2, and then the function main. Then it has console.log main, set timeout, then as a promise, then f2 and main. So let's see how this will get executed in terms of event loop only with those formula that just now I told you, right? So now look into your notes and then look into this. Let's learn this. What will happen? The first thing, main is getting executed. Excellent. So main getting executed means main will go inside call stack. Now I am inside this. Now I'm seeing console.log main. Okay, excellent. So console.log main gets executed. In the console, I get to see something called main. Fantastic. So it comes out. Now I see set timeout. As I see set timeout now, I know what to do. The set timeout will go to this particular section, and this F1, which is nothing but the callback function of set timeout, will go to callback queue. We have learned it already. Great. Now JavaScript will keep executing the main function itself, because it is not going to put this call stack immediately, because event loop is saying, hey, call stack is not empty. You are not going to go there. Stay here. So as main is in the call stack, main will continue to get executed. So next line of main is nothing but this particular promise. Now what is going to happen? As we have this promise, the callback, which you call is anonymous because it doesn't have any name, gets inside the job queue. Now this anonymous function also not inside the call stack. Still, the call stack has main inside it. And so far, the only thing that it printed in the console is main. So it will execute and go to the next line, which is F2. So F2 will come inside the call stack. What is F2? It has a console.log of F2. So F2 gets printed after main. So we have main and we have F2. Excellent. Now F2's execution is over. F2 comes out. Do I have anything after F2 inside main? Oh no, I don't have anything. So main also comes out. Now is the situation, the formula. We have one function in the callback queue. We have one function in the job queue and our call stack is empty. It's time for event loop to act, isn't it? Event loop figured out call stack is empty. Now I have to pull from these queues. Which queue gets precedence? Which queue gets priority? Of course, the job queue gets priority. So it means this anonymous function, which prints I am a promise once it gets resolved, will go to call stack. And as it gets executed, it will resolve and print this I am a promise inside the console.log. So with this console.log I am a promise comes and it gets executed. In the log you get now I am a promise. So you have main, you have F2 and you have I am a promise. Excellent, you are getting it. Now this goes out. Again call stack is empty. Again event loop is in action. Do I have anything inside job queue? Because I want to look into job queue as a precedence? No. Do I have anything inside callback queue? Yes, I have F1. Time for me to pull F1 into call stack. F1 goes inside. I have console.log. So that gets executed. It gets inside the log. So now I get F1 inside the log. So my log is now main, F2, I am a promise, and then F1. So F1 gets over, F1 comes out of the call stack. There is nothing in the callback queue, nothing in the job queue, nothing in the call stack, nothing to execute, nothing event loop has to do now. But important fact is the things that got executed and logged in the sequence in the console. First I got main, then I got F2, then I got I am a promise, then I got F1. Now if you have to just guess looking into this code, you will be just guessing. And your interviewer also will guess like how much you know. But if you think from this event loop point of view, everything, if you just draw in a pen and paper, a call stack, a box, a callback queue, a job queue, an event loop, and you map things the way that I mapped mentally, I think you are going to rock in front of any interviewer. That's what I want. That's exactly I want for you guys. So if you found this helpful so far, why don't you like this video? Post a comment if you liked it. I would be really happy to know your feedback. And also, why don't you subscribe? I really want to know that if you don't want to subscribe, why you don't want to subscribe to tapaScript. Because putting a lot of effort to bring content like this, you can see that it requires lot of time to create these things for you. It is not taken from anybody. It is created by me to bring in front of you. So if you feel it is worth, please subscribe to tapaScript. Please help my channel to grow. That's the support that you can definitely give. And of course, you can also join as a member to support me further. All right, so we understand that. Now let's look into, now it's a testing time for you. Let's look into this code. And I want you to think through what will be the output, okay? And the output will be, of course, written here one by one that I'll be executing it. So let's see. Now there is no diagram. Now I want you to do mental mapping, mentally map what will be the output. So first thing first, main is the first thing to get executed. I go inside main. I see a console.log main, synchronous operation, main gets logged. Excellent. Now I see setTimeout F1. It won't be inside call stack. It will be moved to my web API section. F1 goes to where? Callback queue. Then I see F3. Again, same thing. F3 goes to callback queue. So F1, F3 is not going to execute it immediately. Both F1 and F3 are parked inside callback queue. Are you doing this? Please do this. Please draw that all those boxes like before and start putting things in the pen and paper as I'm explaining, right? Then only it will make sense. And knowingly, I'm not showing it in the visual diagram because I want you to do on pen and paper. Please draw a diagram like this, and whatever I am telling right now, just start putting it. So main has got executed, it got logged. F1, F3 is in the callback queue. Excellent. Now I see promise because main is still inside the call stack. For promise, this will go where? It will go to job queue. After that, again I see a promise. So this guy again will go to where? In the job queue. And then I see F2, which is neither a set timeout, nor a promise, nor a event handler. So it has nothing to do with the asynchronousness. So it will straightway go to my call stack. And the F2 is having a console.log that will be printed. So far I have main and I have printed F2. Correct? equation is matching or not. Now in your callback queue, you have two things, F1 and F3. In your job queue, you have two things. One is I am a promise right after F1, F3 really, and I am a promise after promise. Your call stack is empty. Your event loop is in action. What it is going to pick up first? It is always going to give job queue as a higher precedence than the callback queue. In job queue, you have two anonymous function. One is for this, one is for this. And in your callback queue, you have two functions, F1 and F3. As it gives priority to your job queue, it is going to pull the function from the job queue and put inside the call stack one by one. So is it going to put only the first one, or it is going to pull both of this? Our rule says, our formula says, if there are multiple items in the callback queue and the job queue will be given higher precedence. All the items from the job queue will be executed by pulling them to call stack, and only after that it will look into the callback queue. Correct? That's the formula. So it means now in my job queue, I have this one. This will go to call stack and it will be executed. I am a promise right after F1, F3 really. So you'll get that as a log. Then it will execute the next executor function. I am a promise after promise. Then I get that as a log. Now there is nothing in the job queue. Both the promises are done. There is nothing in the call stack. So now event loop is going to look into the callback queue. Inside callback queue, it finds F1 and F3. Of course, F1 got inside before F3, but as it is set timeout, there is a mapping of timing, like which one has to execute first. As F3 has to execute first, so F3 will go to the call stack first. F3 will be executed, goes out of the call stack. Then F1 is the only thing in the callback queue. So F1 will go to the call stack, get executed, and come back. Then there is nothing else really remaining in the call stack, nothing else remaining in the callback queue, nothing else remaining in the task queue. Everything is done. Nothing else is remaining in the job queue. So nothing that event loop has to do. So the final output, that's why it is main F2. I am a promise right after F1, F3. I am a promise after promise, F3 and F1. This is how you should be thinking. Things are really not complex. It is just that you may not know how things works internally, and now you know how things work internally, so you can give the answer very, very well. As you see here, the same code we have seen just now, I got it here and then executing it for you. So it gives main, then F2, I am a promise right after F1, F3, then I am a promise after promise, then F3 and F1. Exactly how we had conceptualized, exactly that fashion things are getting printed over here. I hope it makes sense to you. Now what you can do to make your understanding much more solid and firm, you need to practice. So I'm going to give you a few quizzes. Look into your task.md file. Each of the quizzes are in a fashion that you have to not only give me the answer, but you also have to explain. And if any of you completing this, please post it on our Discord. Let me take a look into it to understand how much you now know. Because if you are rightly answering all these questions, that means you are actually ready to answer all these questions in the interview as well. Let me give you a sample like how I am expecting these answers. Let's take this question. What is the output of the code below? I have a function f1, then f2, then f3, then f4. Then there is a simple console.log. Then there is a set timeout, which is executing f1 in 0 millisecond. Then f4, then again set timeout, which is executing f2, then set timeout executing f3. And the options are whether it will print let's do it first, then f4, f1, f3, f2, or these options. Now, what I want as an answer, I don't want the answer will be this or this or this or this. Rather, I want you to write the answer like this. Hey, this is the right answer and this is the explanation. Explanation is like this. Let's do it executed by execution stack or the call stack. F1 calls browser API, gets added to the callback queue. F4 gets added to the execution stack. So whatever visually you have learned, whatever you will be drawing on your pen and paper to push and execute all these functions one by one, I want you to write every step. So this one I have done for you for one of the examples. Like this, there are other 6-7 questions. So for each of these questions, please make sure that you are documenting the answer the way I'm expecting. Please complete it. This is for you. This is not for me. I am putting effort. If you are not putting effort, the effort that I am putting is of no use. Hey guys, to be honest, I enjoyed a lot teaching you about event loop. I'm sure that's the case for you as well. And if so, please let me know. Up next, we are going to build a project with everything we have learned in this module, the asynchronous JavaScript module. We're going to build a project and then we will move to the next module where we'll get started with object-oriented programming. Many of you are waiting for it. I know that I get a lot of messages that if I can teach you object-oriented programming, yes, the next module is about object-oriented programming. So why waiting? Subscribe to tapaScript. Keep learning the way fundamentals should be learned. It takes time, but you learn it once and encash it for the lifetime. We'll be back soon with the next video. Stay well, keep learning.